Okay, now we're going to look at the math for a differential amplifier. And so a differential is just looking at the difference between two input signals. And so if we draw that out, we're going to have our op amp. And this is going to be my VB. We're going to call this one R1 and this R2. And we're going to call this one R1. This is going to be VA. So I've got two signals, two input signals. So it's hard to decide whether this is an inverting or a non-inverting amplifier. And so it really is both. So what we're going to do is we're going to split the problem up. So we're going to split the problem, and we're going to first consider the non-inverting input. We're going to treat it like it's a non-inverting op amp. And then what we're going to do is we're going to treat it like it's an inverting input. And then we're going to just add those signals together, and that'll be our output. So the first thing we're going to do is we're going to find what our V plus is. So we want to find V plus is the voltage right here at this point, and we can see that this is just a voltage amplifier, or I mean a voltage divider. So here to here is just a voltage divider, and so we can use our voltage divider formula. So V plus is equal to VA times R2 over R1 plus R2. And so our V out, so right, we're starting with the non-inverting input. So that means we're just going to find the gain for a non-inverting amplifier with an input of V plus. So this is our V plus. So our V out is just equal to V plus times 1 plus R2 over R1. And so what we want to do then is we're going to substitute in. So V out is equal to VA times R2 over R1 plus R2 times 1 plus R2 over R1. And now I'm going to rewrite this denominator here. And the reason I want to do that is because I want to see if I can rewrite it so that I can cancel this term with this. So how do we do that? Well, I'm just going to factor out, so I have VA times R2 over, I'm going to factor out an R1 here. So if I factor out an R1, I get 1 plus R2 over R1. Right, so if you multiply R1 through this, you'll get right back to this term right here. And then this is 1 plus R2 over R1. So these cancel. And so my V out then is just VA times R2 over R1. Okay, so next I'm going to go to my, so I've done the non-inverting, and now let's look at the inverting signal. So if I just look at the inverting signal of VB here, then, and I'm ignoring the non-inverting signal, then I'm going to have, let's do, so this part is non-inverting. Let's do the inverting over here. So I know for V out for inverting is just VB times a negative R2 over R1. So V out then is just negative VB R2 minus R1. And now I putting it all together, right? So putting them together, outputs together, we get V out is equal to VA R2 over R1 minus VB times R2 over R1. And so V out then is just R2 over R1 times VA minus VB. So, so that just means that we can choose our R's so that we get different scaling factors that are multiplied by the difference between our signals. So we have these, you could imagine like two different temperature sensors connected here to this differential, op amp. Sorry about that. If we connected to, say, one thermocouple to VB and a different thermocouple to VA, and we know they're close but not exactly the same, we could then take the difference between them, multiply them by this scaling factor, right, or gain factor, and amplify the difference between the signals. So one of the things a lot of times you can do is just make your R2. So we could just say R2 is some factor times R1, right? And so we can just pick an R1 and then find a multiple of R1 to turn into R2 to give us the scaling that we would like.